Have you ever gazed at the moonlit sky and wondered about its influence on our planet? Beyond its gentle glow, the moon plays a crucial role in a phenomenon we experience every day: tides. The rhythmic rise and fall of ocean levels, a constant dance between the Earth and its celestial companion, has fascinated humanity for centuries. For generations, coastal communities, reliant on the sea for sustenance and livelihood, observed a curious pattern. The ocean, seemingly predictable, would surge towards the shore and recede in a predictable rhythm. This rhythm, the tides, remained a mystery for countless years. Today we know that this mesmerizing dance of the oceans is orchestrated by the moon's gravitational pull. But how can a celestial body so distant exert such a powerful influence on our planet? The answer lies in the fundamental forces that govern the universe: gravity. The moon, though smaller than Earth, exerts a gravitational pull on everything on our planet, including the vast expanse of our oceans. We often think of gravity as the force that keeps our feet firmly planted on the ground. However, gravity's reach extends far beyond Earth's surface, influencing objects across vast cosmic distances. This invisible force, a fundamental property of matter, is what binds the planets in our solar system in their orbits around the sun and, closer to home, governs the relationship between the Earth and the Moon. The Moon's gravity tugs at the Earth and, most noticeably, at its oceans. Imagine the Earth as a giant ball covered in water. As the Moon orbits our planet, the water on the side closest to the Moon feels a stronger gravitational pull. This pull creates a bulge, a gathering of water on the side of the Earth facing the Moon. We call this bulge a high tide. But here's where it gets interesting. A high tide also occurs on the opposite side of the Earth. This second bulge is a result of inertia. Inertia is the tendency of an object to resist changes in motion. The water on the side farthest from the Moon is less affected by its gravitational pull and tends to stay behind, creating another bulge, another high tide. With two bulges of water on opposite sides of the Earth, we have the phenomenon of high tides. But what about low tides? As you might have guessed, they occur in the areas between the two high tides. As the Earth rotates, different locations on the planet pass through these bulges, experiencing the rhythmic cycle of high and low tides. Picture yourself standing on a beach. Over approximately 6 hours, you would witness the water level gradually rising, reaching its highest point at high tide. Then for another 6 hours the water would recede, revealing more and more of the shoreline as it reaches low tide. This cycle repeats, with 2 high tides and 2 low tides occurring each day. The difference in height between high tide and low tide, known as the tidal range, is not constant. It varies depending on the Moon's position relative to the Sun and Earth. When the Sun, Earth, and Moon align, their combined gravitational forces result in more extreme tides known as spring tides. While the Moon plays the leading role in influencing tides, the Sun, our nearest star, is not a silent partner in this cosmic dance. The Sun's gravitational pull also affects tides, though to a lesser extent than the Moon. Even though the Sun is much larger than the Moon, it is also much farther away from Earth. Distance weakens the force of gravity. When the Sun and Moon align, during a new moon or full moon, their combined gravitational pull creates the most dramatic tides, spring tides. During spring tides, the high tides are higher, and the low tides are lower than usual. Conversely, when the Sun and Moon are at right angles to each other, during the first and third quarter moons, their gravitational forces partially cancel each other out. This results in less dramatic tides, known as neap tides. During neap tides, the difference between high and low tides is minimal. Understanding the intricate interplay between the Moon, the Sun, and our oceans allows us to predict and prepare for the ebb and flow of tides. This knowledge is not just a matter of scientific curiosity. It has profound implications for our lives, especially for those who live and work in coastal communities.